Alright, so today, our lesson. Guys, today is a super important lesson. We're going to talk about basically the basics of our whole unit. We're talking about factoring and simplifying expressions. This is a day where a lot of kids end up getting lost or they find it really tough. Alright, so please make sure you're paying attention. Please ask questions today. Alright, I want to answer all your questions, so please make sure you ask them because today is one of the tougher days of the unit. So, an algebraic fraction is sometimes called a rational expression. So, when that question on top of your note says, what's a rational expression? You could write it down as an algebraic fraction. Basically what that means is we have numbers, we have variables in our numerators and denominators. It could be anything. Right? So an algebraic fraction is sometimes called a rational expression. It is simply a fraction where numerator and denominator are polynomials. Right? Where we have x's, we have numbers, we might have different variables, all sorts of things like that. It just means that we have all of algebra in it. It's just a fraction. Alright? So, any questions on that? Okay. One thing to be mindful of when working with fractions, remember the denominator cannot equal 0. We've talked about this. Restrictions. Right? 5 over x can be any real number except 0. Can't equal 0. We've talked about this when we did restrictions on, was that day 1 we did restrictions? Right, yeah. If we had x plus 4 over x minus 5, x cannot equal 5 because it would make our denominator equal 0. Those are all restrictions. Alright? And just like fractions, algebraic fractions can be added, subtracted, multiplied, divided. Today I think we just talk about simplifying them. Later on in this unit, in the next couple days, we'll talk about like multiplying and dividing these sort of things and then simplifying them. All the operations work the same as what we've learned before. Like I said, we're going to start with simplifying or reducing them. Remember, we always want fractions in simplest form, so we are simplifying them as much as possible at all times. And how we're going to do that is we're going to see what common factors the numerator and denominator have and reduce them or cross them out or get rid of them, however you say it. Right? So we're looking for common factors in our numerator and denominator and we're getting rid of them. We're reducing our fractions. So basically it's like reducing a normal fraction, just a little bit harder because we have variables and other expressions in it. Okay? Cool?
Cool.
Alright. Do I need to let you write that down for a second? Okay, I can do that. Stand in your way. Perfect. Alright. We ready to go? Okay, let's try some. Our first one here. 20x to the 4th y cubed over 35x cubed y. If we look at that, do we have any common factors? Chewy, what do we have? Well, let's start with just the numbers. Let's look at just 20 and 35. Is there a common factor there? 5, right? If I take a 5 out of both numerator and denominator, 20 divided by 5 will give me 4. Now, a lot of times I like to write it right away so I don't lose it. 30 divided by 5 will give me 7. Okay? So I looked at the numbers. I did those first. Perfectly fine. What if I look at my x values? Are there any common factors in the numerator and denominator? Aubin, what do you got?
X cubed.
X cubed, right? If I take x cubed out of the numerator, I'm left with x to the first. You can just write x if you want. You don't need to put the first there. If I take x cubed out of the denominator, what am I left with? What? Nothing, right? Technically it's a 1. Technically it's times 1 because x cubed divided by x cubed would equal 1. But we don't need to put 1 because anything times 1 is itself. Alright? And then our y values, what do I have in top and bottom? Just 1y. So I take that out, I get y squared. Take that out, I get just 1. So I get 4 times x times y squared. I get 7 times 1 times 1 is 7. Can I reduce that anymore? No. That's my final answer. And then lastly, wants to know, are there any restrictions?
X and y cannot equal 0.
Both x and y cannot equal 0. Remember guys, yesterday we said, or was it 2 days ago? We said we cannot just look at our end thing. We can't just look at the 7. We need to look where we began as well. Alright, so x cannot equal 0, y cannot equal 0. Now notice, what do we have between all these things when we were simplifying? Multiplication. That is the key. You must have multiplication between terms to be able to cancel those terms. Alright? Because I can guarantee you at least 5 of you, and one of the problems today is going to try and cancel something that has addition or subtraction in between it. We can't do that, right? Because that's connected to each other. If they are being multiplied, then they are different terms, and we can cancel them. Okay? You'll see what I mean when we get a little farther in. Okay, like in the next one here. 2x minus 7 times 3x minus 5 over 3x minus 5 times x plus 14. Do I have any terms that are the same? I do. I have 3x minus 5 and 3x minus 5. Because I have that whole term, I can cancel it. Right? Now, remember I said we had to have multiplication in between? It does. My two terms are 2x minus 7 and 3x minus 5. I have multiplication in between those. So I can cancel out a whole term. I cannot just cancel out an x or a 3. I need that whole term to be able to cancel it. Okay, does that make sense? Okay, so if I rewrite this, I'm left with 2x minus 7 over x plus 14. Can I simplify anything else in this equation? No. Right? You cannot simplify that 7 over 14. Right? We just said we can't have that subtraction next to it. This is one whole term up here. If I plug a number in for x, that turns into one number. Right? So I can't simplify just the 7 away from it. I would have to have 2x minus 7 on both top and bottom to cancel it. Does that make sense?
Yeah.
Okay. So that's the most common mistake we see in this unit. Is people try and cancel like the 7 and the 14. We need the whole term to be able to cancel that. Okay? Does that make sense? At least a little bit? Okay. That is our answer. That's as much as I can simplify it. Now, what might my restrictions be? Or how might I go about finding my restrictions even? Anyone?
Equal to 0.
What'd you say?
Set it equal to 0.
Set what equal to 0?
The numerator and denominator.
Not the numerator, but both pieces in our denominator, right? So remember, our numerator can equal 0 as much as it wants. We really don't care. But the denominator is what can't equal 0. So I'm going to take both my pieces, 3x minus 5, set it equal to 0, and x plus 14, set it equal to 0. Whatever that solves out to are going to be my restrictions, because they make either of those pieces equal 0. So add 5, 3x equals 5. Divide by 3, x equals, I'm going to leave it as 5/3. If you want to put it as 1.666 repeated, whatever, you can. Just don't round it, make sure you write it as 1.6x with the line over it, please. So my other one, subtract 14, x equals negative 14. So those are my two restrictions. So when I write them, I'd write x cannot equal 5/3, x cannot equal negative 14. And I'm done for that problem. Okay? That make sense? Alright, let's look at the next one. 7x cubed minus 21x squared over 6x squared. What do you think I should do first? Can I simplify any of that? Can I just cancel out x squared with x squared?
No.
No, right? That's part of one whole term up here. I would need that whole thing. What do you think I might be able to do to that top part?
Take out x squared.
Take out not only x squared, but like 7x squared, right? Factor first. Guys, I'm going to warn you right now, you should always factor it first before we start to simplify. Alright? We're going to get some problems later on where we have to factor it in like two pieces like we have been. That'll make it way easier to simplify. So if I factor out 7x squared, I get x minus 3 over 6x squared. Now can I simplify anything? Yeah, now I can take and I can simplify x squared and x squared. I have it top and bottom. Right, now I have multiplication between everything up here. Is there anything else I can simplify? No, so I'm going to rewrite it. 7 times x minus 3 over 6. Now, I'm not too picky about it. I don't mind if you leave it like that for an answer. Now, I'm going to rewrite it. I'm going to redistribute that 7. Like I said, you don't really have to. So 7x minus 21 over 6. And that works for me. That's my final answer. Okay? So factor things out first, then simplify them. What are my restrictions? X cannot equal 0. Right? If x equals 0 back here, I get 0 times 6, which is just 0. And I can't have that. Does that make sense? Okay, I want you to try D on your own. Factor first, then try and simplify. Ask questions if you have them. X squared minus 4 is one whole term. X squared. Okay. Okay, we'll go through it. I want you guys to Alright, guys, we're going to go through here in a few seconds. I know most of you might not have finished yet, but I want to make sure we can answer questions on it. Good start. Great start. Alright, let's go through it. Guys, hey, the top part. We have a special term for the top part. What is that called? Starts with a D. Difference of perfect squares, right? X squared and 4 are both perfect squares. Like I said, we should factor everything before we do anything else. So if I factor that, it becomes x plus 2 and x minus 2. I can take the square root of both of them. Square root of x squared is x. Square root of 4 is 2. And I add 1 and I subtract 1. So that's my difference of perfect squares. On the bottom, I can factor this, right? Using either the box method or the guess and check or grouping or star method or whatever you use. You can factor this. It factors to x plus 1, x minus 2. Alright, do we all see that? How it factors? Now is when we can start simplifying. So we need those whole terms to be able to simplify them. So like I have x minus 2 on top and bottom, and I can simplify them. It leaves me with x plus 2 over x plus 1. Can I simplify anything else? No, right? I cannot take these x's and cross them off. They are attached to the 2 and attached to the 1. They are one whole term there. X plus 2 is a whole term. X plus 1 is a whole term. I can't simplify those. So that's as far as I can go. That's my answer. Does that make sense? Are we sure? Okay. Make sure we factor first. Okay. If I have restrictions, what would my restrictions be? X cannot equal negative 1. And I heard someone say the other one. 2. X cannot equal 2. Right? We said we can't just look at the end. We need to look where we began. But is it easy to look at over here? No. Look at your factor part. The factor part will make it easier. Okay? Are there any questions before I move on? Alright, let's try another one then. X squared plus 5x plus 6 over x plus 3. Same thing. Factor first. So I'm going to factor my top part. What does it factor to?
X plus 2, X plus 3.
X plus 2, x plus 3. Do I have any like terms in numerator and denominator? What are they?
X plus 3.
X plus 3. So if I have those like terms, I can cancel them out. I'm left with just x plus 2. Or you can put x plus 2 over 1. Doesn't matter. Both work. Okay, what would my restrictions be then? X cannot equal negative 3. Do not tell me if there are no restrictions. Right? Just because there's no denominator where you end, doesn't mean we don't have a restriction from where we began. Right? So x cannot equal negative 3.
Wait, why is it negative 3?
So remember, because if we put x plus 3 equal to 0,
Oh, duh.
we'd subtract 3, right?
Yeah.
Okay. Good. Alright. Let's try another. 5x squared minus 20, oh, went way far down, over x squared plus 5x plus 6. Factor first. If I look at the top part, what can I do to it? Divide by 5. Take that 5 out. 5 times x squared minus 4 over this factor's x plus 3, x plus 2. We just saw that in the last problem. What is going on here? Why is that lined like that? Alright. Does that help us at all? No, it didn't. No, not yet at least. Can I factor one of them more? Yeah, I can factor the top one more, right? This is a difference of perfect squares again. X squared minus 4. So it becomes 5 times x plus 2, x minus 2, over x plus 3, x plus 2. Now it helped us. Right? Now I have a common factor in both my numerator and denominator. What is it? X plus 2. They cancel out. I'm left with 5 times x minus 2 over x plus 3. Is there anything else I can simplify? No. So, like I said, you can leave your answer like that. I have no problem with it. But I'm going to distribute it back through. 5x minus 10 over x plus 3. And would I have restrictions?
Yes.
Yes, what would they be? X cannot equal negative 3, and x cannot equal negative 2. Right? Because x plus 3, if I set it equal to 0, I get negative 3. If I set x plus 2 equal to 0, I get negative 2. Okay? Does that make sense? Are we good right now? Do we have any questions? Okay. I'm going to skip G. Let's go to H. Let's do H. H is a tougher one. Okay, it says simplify. What's the first thing we need to do?
Take out set X.
What?
Take out X at third on the top.
Take out x to the third and top. Factor out a GCF, right? Start with that. X to the third times x squared plus 10x plus 25 over. What can I do to the bottom? Take out x. Factor out GCF again. X times x squared plus 4x minus 5. Alright. Can I keep factoring them?
Yeah.
Yeah.
Yeah. I can factor both parts that are in parentheses. Right, so use your box method, use your guess and check, whichever way you do. X cubed times, on top it's going to factor, right, what multiplies to 25 adds to 10. It'll be x plus 5 and x plus 5. Over, on the bottom it's going to be what? Multiplies to negative 5, adds to 4, x plus 5, and x minus 1. Okay, so I factored it as much as I can. What like terms do I have that I can simplify? Okay, so x plus 5 and x plus 5. Is there anything else that I have? I have an x out front, right? Out here, I still have multiplication, so I can take an x out of here, I get x squared. I take an x out of here, and it cancels out. It leaves me a 1. So on top, I'm left with x squared times x plus 5. On the bottom, I'm left with x minus 1. Is there anything else I can simplify there? Do not tell me you can simplify this x and x squared. We can't do that bottom part. That x is attached to the minus 1. Alright, so that's my final answer. Like I said though, I would distribute it back through. X cubed plus 5x squared over x minus 1. Now, am I going to have any restrictions? Yes, I'm technically going to have 3 restrictions. What is one of them? Connor.
X cannot equal 0.
X cannot equal 0. Where does that one come from, Connor?
When we factored out the x at the bottom.
When we factored out the x to start with, right? That means x cannot equal 0. If that part equals 0, 0 times whatever will always be 0. So that's our first restriction. What would our second one be?
X can't equal 1.
Where'd you get x can't equal 1 from?
The x minus 1 at the end.
The x minus 1 at the end. If I set that equal to 0, I get x can't equal 1. What's my final restriction, Ange?
X can't equal -5.
X can't equal -5. Where'd you get that one from?
From X plus 5.
From x plus 5, right? Set that equal to 0, we would get x cannot equal -5. Good. Does everyone see where the 3 restrictions come from?
Yes.
Does everyone see how we got our answer? Okay. We're going to do a few more. I know, right? It sucks. We're good. Trust me, they help. We're going to do, yeah, we'll see if we can get all of them in, but I'm not sure. X plus 5 over 5 plus x. What?
X cannot equal -5.
Is that it? We can't simplify that at all?
Equals 1.
You can do what? Cancel what out? But they're not the same. They're flipped, right? With addition, guys, I can move these around. So I can make this x plus 5 over x plus 5. So are those the same terms? Yeah, so I can cancel those. And I get 1, not 0. 1. Right, because it's technically 1 over 1, which would equal 1. Now, I do still have my restrictions. Right? I do still have x cannot equal -5 from that beginning portion. That is still a restriction of mine. Does that make sense? Right? With addition, we can just move them around. Right? What about the next one then? X minus 5 over 5 minus x. Can I do the same thing, just cross them off? No, right? If I switch these around, I get x minus 5 over -x plus 5. Are those the same? No. Is there something I could do to that denominator, however, to make it look like the numerator?
Take a -1.
I could factor out a -1. Right? If I factor out a -1 here, I get x minus 5 over -1 times x minus 5. Whoa. Do I have like terms now? Yeah. So now I have x minus 5 and x minus 5. Right? I'm left with 1 over -1, which is -1. Right, so if you have a negative x value, guys, factor out a -1. Alright? See if that'll help. Alright. Restrictions for that one.
Positive 5.
Ooh. We have a little argument here.
X negative 5.
Do we think it's negative 5 or positive 5? Let's look. Let's set this part equal to 0. Negative x plus 5 equals 0. Minus 5. I get negative x equals negative 5. Divide by negative 1. X cannot equal positive 5. It is positive 5. Alright. Let's quickly try and do the next one. This one should take us about 2 seconds. But look at that. Can I simplify anything? Can I take a negative 1 out to help me simplify anything?
Yeah.
I can.
At the top.
If I take a negative 1 out of there, I get negative x plus 5 over x plus 5. Is that the same? No. So in this case, taking negative 1 out didn't help me at all. It won't help me simplify anything, so it's my final answer. You could write cannot be simplified. That would work as well. Simplify. Let's see if I can spell. What do I do? Simplify, is that right?
Yeah.
Okay. Would there still be a restriction though?
Yes.
Yeah, x still can't equal negative 5. Also guys, I've been doing this a lot, I don't think I explained it. That equals with the cross through it, that means can't equal. Alright, so when you're writing your restriction, you should be using that symbol. X cannot equal. Okay? Just in case. We only have a couple minutes left. It's the same as what?
No.
It is not. I mean, it's close, but it's factor of negative 1. Alright, so we're going to skip the last one.
Thank you.
Remember, simplifying means to reduce the lowest terms. The numerator and denominator have no common factors left other than 1. That's what we're looking for when we simplify. Alright.